I am who I say I am. Today decided to be Batman, but it's okay. I'll provide evidence that I'm Batman. Hello, everyone, and welcome back to Kira Cloud Hub. The AWS Cloud Practitioner Bootcamp series, and today we are actually getting into Module 3. I am who I say I am, mastering AWS IAM, one of my favorite titles so far. We started with an introduction to AWS Cloud, what is cloud computing, and then followed up with the AWS Global Infrastructure explanations. Now, let's get to identity. So, AWS IAM today will be covering identity and access management, which is a crucial component for securing your AWS resources. So if you have ever wondered how to securely or effectively manage our permissions, users, roles, policies using AWS, this is the right video to get you started. So for me, I am who I say I am. Today decided to be Batman, but it's okay. I'll provide evidence that I'm Batman in the next episode. Tune in. So uh, what you're going to cover, will cover some key concepts of identity and access management in AWS. That has to do with IAM users, groups, roles, and policies, as well as best practices for implementing these policies in your cloud environment. After that, we'll just have a bonus short lecture on AWS organizations. And yeah, let's get started. Don't forget to like, subscribe. Let me know your thoughts in the comment section. Okay, so when you create an account for the first time, the account you create, you'll just start with the root user account. And this account normally has full access to anything and everything in the management console. We normally call it going God mode sometimes, because you literally have the privileges to do anything. So that's why AWS strongly recommends not using the root user for day-to-day activities. So instead of using the root user, you would rather create another user called an admin user or an administrator, and use that account to do your daily operations. Yeah. And then, of course, best practice, yeah, use multi-factor authentication for security of both your root user account and also the admin user account you're going to create. Moving on to the console a little bit. So going to AWS, yeah, the AWS page, you can create a free account and sign up. So you can see for the details over here, the first thing you are asked is the root user email address. The email address you'll use, you verify your account, verify your email address. You'll be asked a few other things, just the simple setup of creating an account, okay? Some credit card details, and then you sign in. Now, if I go to the sign in page, there are two ways in which I can sign in. So for the first time, of course, you'll have to sign in using your root user email address. In this case, uh, signing in as a root user, you'll use the email address. So I'll just select that. And yes, the console loads, the management console, you have access to the dashboard over there. But what you'll notice over here is basically now my name is J Pauline with my account ID over here. And that is how you sign in using the root user account. So basically, as a root user account, I can do anything. I have permissions to uh, do anything I want over here. So don't use that for daily activities. And that's when we get into the service called IAM, Identity and Access Management. So IAM, it's actually a service that enables us to control access, to securely control access to our AWS resources. So we want to control who is authenticated. That is the first step, which is signing in. And authorized, that means has permissions, or what can they do in their AWS account. So identity first, where you authorize, you authenticate someone, and access, where they are authorized or have permissions to use specific resources. So with identity and access management, you also get like permissions which define what you are allowed to do in that specific account. And these permissions are managed through the policies, which we'll talk about. And policies are applied to IAM users, groups, and roles, which we'll figure out in a moment. So identity and access management offers us this centralized management where in one space, we can just manage our users, groups, and configure permissions. What are they allowed to do in that specific account? So, a concept of IAM that you'll basically interact with is the concept of principals. And principal in AWS, it's just an entity that can do any operations on AWS resources. So as I was talking about creating IAM users or so, these are called principals because they can perform actions against AWS resources. So we have users, roles, but these are not the only things that can be principals. Even AWS services, if they can request an action or do an operation on another AWS resource, for example, a server needs to access a storage solution, yeah? The server is performing an action on another AWS resource, then that server can be a principal, okay? So not only users or roles, but services can be principals, external identity providers. For example, we have this concept of federated users, where instead of managing users directly through IAM, we can allow those users to access AWS services through their external identity. And we have identity providers, for example, things like login with Amazon. I'm sure you have interacted with some websites where you can just access that website using your Google account or Google credentials or Facebook credentials. So that is the concept of federated users, where the identities are not managed through IAM as a service, but these are also examples of principles. And that takes us directly to the concept of users. So, who is a user? We talked about logging in through the root user, but an IAM user is just an individual user in a specific account, and they always have their own set of permissions. So, they have some policies attached to them that define what they can do in that um, AWS account. So even for the users, it's best practice to enable multi-factor authentication for them and implement a password policy. Now, there are various ways in which users can access AWS services. And one of the ways, the management console, which I showed you in a bit, and we'll also log into that. But we also have a command line interface for AWS where we can get programmatic access to AWS resources. And we use a different set of credentials called the access key ID and the secret access key ID, which I'll show you in a moment. And also we have the software development kit, which also offers programmatic access to AWS resources using familiar programming languages, okay, like Python, Java. Yeah. So for coding access, you can utilize the software development kit to perform actions against AWS resources. Now, um, what are access keys? These things that enable us to access AWS services programmatically. These are generated through the console, and it consists of a key, access key ID and a secret access key, which you can uh, compare to a username and a password. And one of the best practices when using IAM, you should never share these access keys because they are confidential to you. Treat them like your passwords. So some of the best practices, of course, apply the principle of least privilege, which is a very common concept over here, where you should actually give users only the minimum permissions they need, just the uh, minimum permissions possible. And of course, I've talked more about enforcing multi-factor authentication and enabling strong password policies. Back to the console. Um, so right now, I'm logged in as a root user, and we are talking about identity and access management. To access a service, you can just search for it, and here it is, IAM, and click on it. So through the IAM dashboard, remember I am now using my root user credentials, which I shouldn't. So first things first, after creating your account is to come to identity and access management and create a new user to use for your account. So you can see things, some configurations over here, like I have 5 groups, I have 14 users, 98 roles or so, and policies over there. So to create users, it's just simple. You come over here at the left and create a user. So I'll call this the Cloud Bootcamp or Cloud One. Okay. And you can remember the access to the AWS Management Console, which is this, is optional. So you can give them access to the Management Console and say, I just want to create an IAM user. You can either allow them to auto-generate a password or create a custom password for them. So if you're creating a custom password, we can just create one here. And you can enable this where users must create a new password at the next sign-in, which is recommended or not. So I'll just leave that, uncheck that. And yeah. So next things is to set permissions. So by default, a user does not have any permissions and they cannot do anything. So you can either attach permissions by adding that user to a specific group, or copying permissions from other users, or attaching a policy directly. So I'm going to skip all this. And so you'll notice that I've not created any permissions for them. And here it is. So we have like the console sign-in, which I'll just open in a new incognito window. I have the username over here and the password. So username is cloud1, password is this, and I can sign in. So I am signing in as an IAM user and not a root user instead. So no recently accessed services, but I'll just try and go to identity and access management, maybe search IAM. And now you'll notice something. So they're basically being denied access to do anything. So they don't even have permission to get account summary, or they don't have permission to list some access keys. If I go to users, they don't have any permission. So if you don't attach any permission to a user, then they basically can't do anything in AWS. So I'll just return to users list over here. Continue. And give our Cloud One user at least IAM permissions. So I'll just click on Cloud One and add permissions to this user. And so I'll attach permissions directly in this case, and I just want IAM full access, only identity and access management. IAM full access. So here it is. Okay. Add these permissions. and just refresh this page. And now our Cloud One user is able to view all the users in that specific account because we have attached. Now you have all permissions available to deal with the identity and access management. So next thing I wanted to show you is the security credentials bit. So you'll notice for the root user account, you log in using your root user email address, password, and optionally multi-factor authentication. For an IAM user access, it's different. You don't use an email to log in, but you use your username and a password, and optionally multi-factor authentication. So you can see right now, if you check over here, I have the account ID, but also the details. I'm logged in as an IAM user who is Cloud One. But here, if I look at my account, I just have J Pauline and the account ID. So that shows that I'm logged in as a user instead. Next things, I would want to check the security credentials over here. And I have the console sign in. But if I want to make any programmatic calls to AWS, maybe from the CLI, SDK, or do any direct API calls, then I have to create an access key for my account. So I can say, okay, this access key, I'm going to use it on the command line. I understand the recommendations and just create an access key. So you'll notice I have like an access key, which looks like this, and I'll show you the secret access key because I'll delete it right now. So we have the access key and the secret access key. So you can download it as a CSV file. Whenever you are done saving, you won't have access to this again. So you have to make sure maybe you download the CSV file or just save this somewhere safe. I have the AWS CLI installed, so I'm just gonna say AWS version to check that. And I have the AWS CLI version 2 installed. I have to configure my credentials first. AWS configure, and then I copy my access key ID and secret access key. The default region being US is 1 is okay. Then default output format JSON is okay. Cool. So let me run a command against IAM. For example, list users. And you can say get the details about all the users. So I have an Amos, architecting admin 1, 2, architecting analyst, and more and more and more and more and more. Okay. So if I maybe try AWS S3 list to see the buckets I have with these credentials. So you can see I get an access denied when calling the list buckets operations because the credentials I'm using, Cloud One, is not authorized to perform that action. So that is how we use the access key and the secret access key. You should not share that. And if you're done using it, then you can actually delete them if you want to and create new ones whenever you need to. So I'll delete that in a moment. And that is the concept of IAM users, groups, and how to use your access key. So next thing, with an IAM user, we have to set up permissions with them, okay? So, and remember, use the principle of least privilege. For example, if we have an S3 administrator, then they should only have Amazon S3 full access. But if it's an auditor, maybe you want to give them read-only access to EC2 and S3. And it's really simple to set this up. So going back to the console, because Cloud One has IAM full access, they can actually create users, give them permissions also. So let's see. Uh, so this is S3 admin. Uh, maybe not, but we can just attach a policy directly to them. this user needs S3 full access, Amazon S3 full access. And if it's an auditor instead, we can just use the AWS managed policy like the EC2 read only. So we have the Amazon EC2 read only access, and maybe then select the S3 read only access and then just create a user. So that is how you can set up permissions with IAM policies, and we'll also see how to create your own permissions in a moment. Before that, let's talk about the concepts of groups. And a group is basically a collection of users. So for example, if you have the developer group, which contains maybe Abdul and Joseph, you can add them to that group, and then they'll inherit the permission of that group. So one thing to note is a user can belong to multiple groups. For example, you can have Joseph being both in the developers group and the audit group, and he will inherit permissions from both the developers and the audit team. And groups cannot contain other groups. If you want that setup, then we have the AWS Organizations, which we'll discuss in a few, that will enable us to get that setup. And users do not have to be part of a group. For example, our Cloud9 user, one user which we created, we did not add the user to a specific group. So how does this work? Back to IAM. So it's as simple as creating groups. Okay, so you can actually create a group called dev. I think I already have the dev team. Maybe I can create the audit one. I'll name this group audit. And yeah, you can add users to that group. For example, our Cloud1 user to the audit group. And maybe I have a user who does auditing, the architecting auditor. So architecting auditor and Cloud1. So those two users. And which policies am I attaching to this group? So I'll just go back here and then maybe say the auditor needs Amazon EC2 read-only access and Amazon S3 read-only access. Going back, so I'll just select EC2 read-only access and Amazon S3 read-only access. Cool. So, and create user group. So now if you go to our audit group, so it should have like 2 users in it, and the permissions are defined for that group. Now we go to the Cloud1 user, see the permissions we have. Okay, so we can see this user is attached to one group called the audit group, and the policies that are attached to this group are Amazon EC2 read-only access and S3 read-only access. These services will be discussed later in the course. So now with the permission policies, you will notice for the Cloud1 user, we have IAM full access, which was a permission that was attached directly to this user. But then we have the Amazon EC2 read-only access and S3 read-only access, which are permissions that Cloud1 has inherited from joining the group named audit. So now if we, for example, try to access the EC2 service, okay, so we can see here we have like KPIs around 11. We have some security groups, which you can view because we have like read-only access over there. The instances, 0 are running, but you should be able to view them. But we shouldn't have a permission to maybe launch an instance in this case. But we can view the instances that are available in North Virginia. So we have like an Ubuntu server over there, but we cannot perform any action on it. We cannot launch an instance. If we try, we'll get an access denied error. So that is the concept of groups. And moving forward, we'll go to something really interesting called IAM roles. And with IAM roles, here we gain like temporary credentials, and we assume either users or services can assume these credentials to perform actions on AWS resources. I tend to think as roles just in the physical setup whereby uh, I am Pauline, but by daytime I assume a role as a teacher, and maybe by night time I'm a gamer or whatever you can do. So these are different roles you can take temporarily, but uh, by the end of the day, I'm back to being Pauline. So in case you want to perform any cross-account access, I want to allow users to maybe access some resources in my account, I can give them roles that they can assume to um, gain access to my account. Or you want some third party services to have limited access to your resources, roles are a good way to go about this. And of course, you assign permissions to roles. Their roles can be assigned to users, and also roles can be assigned to services. For example, if I want my instance, my server, to be able to access maybe an object from a storage solution, then I give it a role which grants it that temporary permissions to do whatever it wants to do. Back to the console too. So I'll go back to IAM and maybe open it in a new tab. So I have roles over here, and you can see a role is an identity you can create that has very specific permissions with credentials that are valid for short durations. And we have lots of AWS managed roles, and their service roles. For example, the API gateway service, the CloudFormation service can have this specific role that it can assume. But creating a role is really simple. You can create a role for either an AWS service. Remember, as I mentioned, you want a service to perform actions in that specific account. You can assign a role to an AWS account. You can assign a role to a web identity, whereby you allow users who are federated by external web identity providers, for example, Google, Facebook, Amazon, to assume that role and perform actions in your account. So I'm going to create a simple role for an AWS account. It should be, so it can be in your own account or another AWS account if I want cross account access. So I'll say that is for this account and does not require MFA or all those sorts. Next. And the permissions. So what permissions is that role allowed to do? So in this case, list privilege, let's give it a stray full access. So S3 is just a storage solution, Amazon Simple Storage Service, and we'll get to that soon. So this role has S3 full access only. And next, so we give it a name, um, maybe S3 role, it has full access. Okay, description uh, gives full access to S3. And now you have to select trusted entities who can assume this role. So it could be just, for example, anyone in this AWS account, or you can be specific and give like a specific user. For example, in this case, only the IAM user who's Cloud One can assume that specific role. So I'll go ahead, create this role. And view that role. So you can notice here it has a maximum session duration of 1 hour, which I can edit. It has S3 full access, who is trusted to assume this role. So you can edit the trust policy over here and just specify, in this case, maybe Cloud One. So the ARN of a specific user. I'm going to open this again in a new tab. So let me get the Amazon resource name of the Cloud One user. And here it is. So that is the ARN. I'm going to copy that and edit the trust policy such that only the Cloud One user is trusted to assume that role. Not that one. And update the policy. Okay, so only the user Cloud One is allowed to assume this role. And how you assume that role is you go over here. So as Cloud One, I have this ability to switch role over here. And I'll just give the account ID, the IAM role, I think it's called S3 role, and switch role. And now you'll notice that I don't have permissions to IAM. So when you switch to a role, you lose all your previous permissions. And you can see now I am logged in just as I am currently active as the S3 role. So I don't have my full IAM permissions as I had before, but I should have the S3 permissions that I wanted. So I'll go to storage and choose S3. Because I know I have S3 full access. So when you switch a role, you can only do whatever that role has permissions to do. You lose all your previous permissions and gain the permissions of that specific role. Because of full access, I can view all the S3 buckets in my account, but I don't have permissions to do anything in identity and access management. So that is the concept of roles for a user. I'm going to switch back to my Cloud One account. So that is how you create roles for users. You can also create roles for AWS services. In this case, you're going to choose the specific AWS services that you want to create a role for. So it could be a service like EC2, which is a server in the cloud, or Lambda. So commonly used services. So I'm just going to select EC2 and maybe access to get objects from S3 bucket. And that takes us to the concept of IAM policies. By what we have learned so far, so we have an IAM policy, we have an IAM group, and an IAM user. So, and also IAM roles in this case. So one thing we have noticed is an IAM policy can be assigned to an IAM user. An IAM policy can be assigned to an IAM group, and an IAM policy can be assigned to an IAM role in this case. But roles are assumed. So roles can be assumed by a user. A user can assume a role. A group cannot assume a role. But if we have AWS resources, for example, EC2 instances, AWS resources too can assume a role. So this is assumed. these two assume, but assign. Okay. So what are the various types of policies that we have available? So we have two types. We have policies that either grant permissions or set maximum boundaries. And we'll start off with the ones that grant permissions. So with the policies that give us permissions, we have the identity-based policies. An example is the policy that we are creating for the users with the groups. We attach policies to IAM identities, users, groups, or roles, and those are identity-based policies. They give us permissions. And we also have like resource-based policies that are attached to AWS resources. Apart from that, we have another set of policies that help us set maximum boundaries but do not give us permissions. So they act as guardrails. What are the maximum set of permissions that you can use in this case? So we have the organization service control policy, which we'll discuss in a moment. But these policies define how much can you do. And we also have a set of policies called the IAM permission boundaries, which define the maximum permissions that anyone can receive. So they work hand in hand to grant us the principle of least privilege. Let's start off with the policies that grant permissions in this case. So we have the identity-based policies. And here's an example of an identity-based policy. A policy consists of these things: a version, which an effect, action, a resource, and a condition which is optional. So a version just specifies the language syntax, rules, and then we have the effect. Effect defines whether you are allowed or denied to do whatever you want to do. So the in effect, it can either be allow or deny. What are we allowing or denying? That is the action. So you must specify the list of resources to which the actions apply. So in this case, we have this specific EC2 instance or all instances in your account. Um, you are allowed to start and stop that instance. And then we have the condition, which is optional. So you can make a condition over there which says that uh, the tag, the resource tag, which the key of that resource tag is the owner should be that specific username that you put over there. So this is a structure of a policy, of an identity-based policy. And going back to the console, we'll just see this in a moment. So we have been using AWS managed policies all along when we created policies, but you can create your own policy. And you can either use the policy editor, which is visual, or just create the JSON documents, because policies are JSON documents. In this case, if you know how to write your JSON document, you can just say effect, allow, what actions on what specific resources. But if you're not used to that, you can use the visual builder. In this case, I choose a service. So I'll say the service is EC2. So it can either be all actions, but you want to give the minimum possible. So I'm looking for MN or PQRST. So someone is allowed to start and maybe terminate the instances or stop the instances. So those are very specific. And do you want a specific resource or all resources? So I can say allow this on all EC2 instances if possible, and then it will use a wildcard, or I can just say a specific instance and I have to add that specific ARN, the Amazon resource name of that specific instance. So in this case, to make it simple, I'll put all, and you can see conditions are optionals. So I can put that and then click next. Okay, so we can see we have like limited write access, and we can go ahead and create that policy. So we can see majority of them are AWS managed. I can filter by customer managed to make it easy. And EC2 Cloud One policy is here. Customer managed means it's created by me. And let's see the permission. So it has EC2 limited right. Let's view the JSON version of this. And you can see, so it was created through the visual editor. The effect is allow the action terminate, start and stop instances. And remember, we selected all resources, but you can be specific and give the Amazon resource name of the specific instances that a user is allowed to access. So we can now go ahead and attach this policy to a user. So back to our Cloud One user. So we can go back here and add permission and attach a policy directly. And in this case, I'll choose the customer managed EC2 Cloud One policy. It's as simple as that. So we have the identity, that is an example of an identity-based policy because we attached that to an identity. Now we have examples of resource-based policy. I'll just show you a sample. Going to S3, for example. I hope this is public. Let me just check. Okay, it's private. But you can see an example of a bucket policy. Remember, resource-based policies attached to a specific resource. And now we have one additional thing called the principal. So in this case, if we are attaching a resource, a policy to a resource, we have to specify who is allowed. Remember, for identity, we have just attached the policy to an identity itself. It's like if I go, for example, to a movie, I'll carry my ID, and then because I have my ID, I'll just show it, and that defines my identity. But in other cases, maybe they have a list of who is allowed to come in. So in that case, the policies are attached to the resource itself. So in this case, if it's the guard, he will have a list, and then when you go there, instead of you showing your identity, they'll just cross-check, is your name in our list? So in that case, this is a policy attached to an S3 bucket. So it has allow all actions on S3 on this specific bucket called architecting 2602. But now we have to add the principal, which defines who is allowed this specific action on this resource. So you can either be very specific and give the ARN of someone specific, or say everyone is allowed access to this specific bucket. So those are policies that grant permissions. So we can either allow or deny access in our policies. And we have a policy of evaluation logic that allows us to understand how things are done. It will check for a deny. And then, so if there is any deny and you are like, okay, yes, there is a deny, then the final decision will be automatically deny in this case. So this is a yes. So if there is no deny, then we are going to check if there is an allow in this case. So the deny is no in this case. Is there any allow? Then if there is an allow, then the final decision will be allowed. But if there is no allow, then it will deny. So this is what we call an implicit deny. And this is what we call an explicit deny. So explicit deny, because it was written in the rules first, we are denying. But if there is no allow rule, then it will implicitly deny that specific action that you're trying to do. So this is how policies are evaluated in AWS. And now we talked about another set of permissions which was used to limit the user permissions. So in this case, we had two policy types, some that grant permissions and some that give maximum permissions. So we are either granting permissions or defined max permissions. Here we are talking about, we have the types of identity-based policies, that are attached to a specific either user, group, or role. And then we have resource-based policies that are attached to resources. But the ones which define maximum permissions, so we have, for example, the permissions boundaries that we're talking about. And then we have the service control policies that we'll discuss in a few. These are attached to organizations, basically. So what happens is we use the permissions boundaries together with the identity-based policies to specify what a user can do. So the only permissions that will be allowed are the permissions which are allowed by the permissions boundary and also by the identity-based policy. But remember, the permission boundary will only give the maximum permissions, while the identity-based policies are the ones which give the permissions. And we'll look at an example when we get to the service control policies and see how they work together. So back here, we are done with the policies bit and getting into the last section where we talk about organization. So sometimes you might want to have multiple accounts, and yeah, you want to group resources together, maybe create a hierarchy structure. And remember, as we talked about groups, even though they are very important for giving permissions, we cannot have groups inside of other groups. So you might want to use a multi-account strategy whereby you group resources for categorization, you want to improve your security posture, um, and that is where AWS organizations comes in. So with the AWS organizations, you can centrally manage all your AWS account, and it offers this consolidated billing feature, making sure that when the bills are consolidated, then you uh, pay less, basically save money. And if you want hierarchical grouping of your accounts, then the AWS organizations is a good way to go about this. So we have policies. You can set up the policies in forms of service control policies to centralize control. It has integration with other AWS services and also identity and access management. It has global access and no cost for use, but you are charged for whatever you use for the resources you create over there in the AWS organization. So this is a form of a structure. So we have the management account, which will be your account that you use to create an organization. And then we can divide them into small groups, which are called organization units. So you can divide them into organizational units, for example, dev, prod, and inside an organization unit, you can have another. This setup is not possible with IAM groups. So you can have accounts in specific organizational units, multiple accounts or just one account, an organizational unit inside of another, and control this with policies, service control policies. And that brings us to the service control policies overview. So these are still policies, but they do not give permissions. They only define maximum permissions that your accounts are allowed to use. So they have to be combined with maybe identity-based or resource-based policies to grant permissions. Otherwise, you cannot use service control policies to grant permissions on its own. So we have an example over here where we have an service control policy that allows EC2 and S3 actions all. And then we have an identity-based policy that allows EC2 and an IAM actions. So we'll see the effective permissions. I think whiteboard will help over here. So let's put that up. Okay. So this is a service control policy for an organization. And then we have the identity-based policy. And in our example, we were saying that the service control policies allows S3 full access and maybe EC2 full access. And then we have the identity-based policy that allows EC2 full access and IAM full access. So what is the set of permissions that will be allowed here? Remember, the service control policy defines the maximum amount of permissions. So what will happen in this case, first things first, is IAM will not be allowed because even though it's attached to a specific identity, the maximum set of permissions that service control policy has offered is Amazon S3 full access and EC2 full access. So it's basically we are getting to the middle. Only the permissions that are allowed by both the identity-based policy and the service control policy will be allowed. So in this case, it will be EC2. So only EC2 will be allowed because it's allowed from both the identity-based policy and also the service control policy. Because this user does not have S3 attached over here, remember the service control policy does not give permissions. So S3 will also be declined in that case. So only EC2 will be allowed. And that is just what that explanation meant. Where the effective permissions are all EC2 actions, S3 and IAM actions will be excluded. So we have an example of a hierarchy over here. This is from Stefan Marik's course content. So whereby an example of a hierarchy, we have the organizational unit, root, we have the management account. One thing you need to know is the management account can do anything. So the service control policy do not apply to the management account. So even if you say you have denied Athena, the management account can still do anything. But if we look at account A belongs to the sandbox organizational unit and also the root organizational unit. So they can do anything except they deny S3, which has been denied from the sandbox organizational unit, and they have denied EC2 access from their own specific account. The account B and C can do anything just except the deny S3, which was denied from the sandbox organizational unit. And then we have account D, which belongs to the test organizational unit, which is only allowed EC2. So they are not allowed anything else. So that is the only thing they can do because the service control policy that is allowed attached to the organizational unit only allows access to EC2. Remember the SCP set maximum boundaries in that case. So the maximum boundaries attached there is to allow EC2 only. And then we have the account E and F, which belongs to the prod organizational unit. They do not have any deny attached to them from the workloads OU, from the prods OU, then they'll have full AWS access and they can do anything. So that is an example of the SCP hierarchy in that case. Please, not everyone needs to be an admin in their account. Yeah, we don't want to cry. So remember to always set the minimum permissions possible, use the principle of least privilege. And yeah, that wraps up access, identity and access management. IAM with an additional organizations in it. I hope you learned something. Yeah, see you in the next section. We'll be diving into networking in AWS. Bye bye.